All right, this is Algebra 1B Part 1, Unit 4, Lesson 3, Solution Sets. And let's go ahead and get started here. I've got the wrong screen up. Okay, so a solution set is the value or values that make an equation true. In this case, I have what we call a linear equation, 5x plus 2 equals 17. Let's go ahead and solve it. These are steps that hopefully you recall. Undo. Opposite of plus 2 is minus 2. 2 minus 2 is 0. So we get 5x equals 17 minus 2, which is 15. And then divide by 5. Divide both sides by 5. And we end up with x equals 3. Okay, and what we're introducing in this unit is something called a solution set. The solution set is a set of all numbers that make the equation true, and we put them in curly braces. So the solution set is 3. Now, solution sets can be empty, they can be null sets or empty sets, they can have 1, 2, or even infinite values in them. But we use curly braces to indicate solution sets. All right? So solution set, curly braces. Okay, next example. I've got this equation, 2x plus x equals 3x. And if I try to take the steps to solve this, 2x plus 1x is 3x. 3x equals 3x no matter what. In fact, if I wanted to, I could divide everything by 3 and get x equals x. And yeah, of course, x equals x. If x is 5, 5 equals 5. If x equals 2, then 2 equals 2. If x equals a million equals a million. No matter what value x takes, it is true. And so we indicate this by the solution set of all real numbers. Now this fancy looking R, you draw two parallels, right? And then draw a capital R. It stands for the real numbers, which includes all rational and irrational numbers. Okay, so that's the way we indicate the set of all real numbers. If your solution set is everything, use the fancy stylized capital R. Just for your information, N with a capitalized is natural. Okay, it's actually an I, but it looks like a Z. It stands for integers. And W stands for whole. But we're going to use only the real numbers in this lesson. Okay. There are circumstances where we might stick to just whole numbers or natural numbers, depending on the situation. Okay. Consider this problem here. I'm going to distribute the 6 and see what we get here. 6 times x plus and 6 times 3 gives me 6x plus 3. Combine like terms on the left side. 2x's plus 4x's are 6x's. And so I get 6x. And if I subtract 6x from both sides, which is a legal step here in solving equations, I get this equation. I get 0 equals 3, which is a false statement. Right? That's a false statement. That means this equation is false no matter what x is. It simply is false. And so the solution set is empty. The empty set is a curly brace or a pair of curly braces with nothing in it, or a circle with a diagonal slash through it, which stands for the null set or empty set. Okay, null or empty set. Okay, next example, consider the equation x squared equals 64. And we understand, hopefully, that the opposite of squaring is square rooting. But there are actually two solutions to this problem. Two solutions. x could be 8, because 8 squared is 64. But x could also be negative 8, because negative 8 times negative 8 is 64. Negative 8 squared, which is negative 8 times negative 8, is also positive 64, just like 8 squared, or 8 times 8, is 64. So when we solve what we call the quadratic equations, equations with x squared, we'll typically find there are two solutions. So the solution set here in this case is curly braces, negative 8, comma 8. Negative 8, comma 8. Okay, so we can have more than one solution. We can talk about solution sets for inequalities. Now, one of the things I do note in this lesson, it doesn't teach you how to solve inequalities. So in this example, negative 3 times the quantity 2x plus 4 is less than 5x plus 4. The solution to that is x is greater than negative 16/11. Really all it's going to ask you to do in this lesson is to rewrite that as a solution set. And here's the way we write it. Here's the way we write it. We're going to write it x in curly braces such that, so a big long bar or a colon, I prefer the big long bar myself, such that x is greater than negative 16/11. Okay, and this bar or colon means such that or so that, x such that x is greater than negative 16/11. And that represents an infinite number of solutions, because there are an infinite number of numbers that are greater than negative 16/11. Okay, and our last example here, another one here, I've walked through the steps. You do not need to know the steps for solving an inequality, but this is what's known as a compound inequality. We started with 8 is less than 4x plus 2 over 3, which is less than 32, which is another way to say that 4x plus 2 divided by 3 is between 8 and 32. Okay, and I've found the solution set. Again, don't worry about the steps for finding the solution to a compound inequality yet. We're going to deal with that later. But how do we write this compound inequality? X is between negative 5.5 and 23.5. We write it this way, curly braces, x such that x is between 5.5, or 5.5 is less than x is less than 23.5. Okay? So set notation for giving solution sets to an inequality.